Good morning, good morning to all. This is a next lecture of sets. In previous lecture, we discussed some definition related to set and symbols like this belongs and doesn't belong, and two representation of sets roster form and set builder form. Okay. In previous class, I have also discussed empty set and singleton. I hope you remember and what is empty set. Empty set representation is this. Singleton is only one element in there and finite and infinite. And I say you have to remember only these two sets, real number and rational. But this is not a correct. I apologize to all. Now we see again these definitions and some example so that you understand well and connect it. Okay, now let's start. First of all, what is here? This is a definition of a empty set. Okay, the definition of empty set. What is empty set? A set which does not contain any element is called the empty set or the null set or the void set. Okay, these are similar names for empty. What is null, void? Okay, wait for a second. According to this example is very good. This example is given in NCRT. What is that? They say let a set A in which the number of students studying in class 11, okay, class 11 में जो बच्चे पढ़ते हैं उनका नंबर, and set B is the number of students that studying in both class 11 and class 10. Okay, this is impossible. A student is studied only in 11th or only in 10th. So this is a set, finite set, and this is a empty set. So that thing they convey in this. According to the definition, B is an empty set while A is not an empty set. An empty set denotation is given here. Y and two curly braces. In that braces nothing is there. Okay, this is empty. Now look some very good examples. What can say? Let A equal to X set in set X such that 1 X x is less than 1 and greater than 2, x is a natural number. We know that the natural numbers are 1, 2, 3, 4, 5 and so on. But they say the natural number between 1 and 2. So there is no natural number between 1 and 2. So this set is empty set. This is a very good and classic example. Now B. X such that x square minus 2 is equal to 0 and x is a rational number. Going back to in class 10th first chapter, you have to prove that x square is equal to 2 implies x equal to root 2 and root 2 is an irrational. So this set is also an empty set because there is no rational such that x square minus 2 is equal to 0. Okay, this example is also I have discussed previously. X is an even prime number greater than 2. We know that the only even prime number is 2. But they say x is an even prime number greater than 2. So this set is also empty. There is no prime number greater than 2 that is even. I hope you understand. Fourth one, x such that x square equal to 4, x is odd. We know that x square is equal to 4 implies x is equal to minus 2 or 2, but they say x is odd, so this is not a case. Any number such that x square equal to 4 and x is equal to odd. So this is also an empty set. These are very good examples for understanding the concept of empty set. I hope you understand all. Okay. Now, second, we have to discuss finite and infinite. Finite and infinite. Okay, I also said tomorrow that you have understand well in graduation, but now the NCERT definition is here. Now we discuss it. What is this? A set which is empty or consists of a definite number of elements is called finite. Otherwise, the set is called infinite. Okay, क्या आया हम लोग के बीच में? If a set is empty or a set having finite number or elements is called finite set, otherwise infinite. Okay, now let's see some examples that makes our concept clear. Now see what are they. State which of the following sets are finite or infinite. Okay, finite or infinite. X belongs to n and x minus 1, x minus 2 is equal to 0. We get two numbers here. What is 1 and 2? They both are natural numbers. They both are natural numbers. So this is a finite set. What? This is a finite set. Okay. X belongs to, next one is x belongs to natural number x square equal to 4. When you solve this, you get x is equal to minus 2 and 2. But here it is given x belongs to natural number. So minus 2 is not a natural number, minus 2 is integer, we have only 2. So this is 2. This second set is only 2. This is also called singleton and finite. I hope you understand. Now x belongs to natural numbers such that 2x minus 1 is equal to 0. When you solve this, x is equal to half. But half is not a natural number, half is a rational number, so this set is empty. But in that definition, a set which is empty is also considered as finite set. So this set is also finite. Now x belongs to natural number and x is prime. We know that primes are natural. So what are they? 2, 3, 5, 7 and so on. And that is infinite in nature. So this set is infinite. Okay, I hope you understand. X belongs to n and x is odd. This set is also infinite because natural number we know odd are 1, 3, 5, 7, 9 and so on. This set is also an infinite set. I hope you all understand and you all connected with that. The most important thing is infinite we have to consider also a empty set and a set in which we count the elements. We count the elements. Okay, I hope you understand. Now let's go. Today also we discuss the definition of equal sets. What is equal sets? What is equal sets? Okay, so what is this? Given two sets A and B, if every element of A is also an element of B, and if every element of B is also an element of A, then set A and B are said to be equal. Clearly, what this definition says that two sets have exactly the same elements. Okay, now let's see two sets. This is also a definition. Two sets A and B are said to be equal if they have exactly the same element and we write A is equal to B. Otherwise, the sets are said to be unequal and we write A is not equal to B. Okay, let's say I write a set, say 1, 2, 3, 4. This is a set. And I write B like that, n such that n belongs to natural number and n is less than equal to 5. Okay, this is in roster form, this is in set builder form, but both have same element. What is the elements of B? 1, 2, 3 and 4 because less than 5. Okay, so we get that. That means A equal to, otherwise we didn't get it, we say A is or say P is not equal to Q. Let's see some very good example. A equal to 1, 2, 3, 4 arbitrary set and B equal to 3, 1, 4, 2. 1 is here, 1 is here, 2 is here, 2 is here, 3 is here, 3 is here, and 4 is here. So this implies A equal to B. I'm not talking about that basic example. I've talked about that. What is? Let A be the set of prime number less than 6. So write A. What are A? A be the set of prime number less than 6, 2, 3, and 5 only. And P the set of prime factors of 30. What are prime factors of 30? When you do a prime factorization of 30, 2, 15, 3, 5, 5, 1. We get only a single one. So this is prime factorization 2, 3, 5. The A and P are equal. Yes, A and P are equal. Since 2, 3, 5 are the only prime factor of 30 and also these are less than 6, this implies A equal to. I hope you understand very well. Today we have all discussed the examples of empty sets, singleton one, finite and infinite, and also one thing add is called equal sets. Tomorrow I will discuss the subsets and some properties. For today it's enough. Thank you. Please like and subscribe.